Here's the 18th problem. It reads consider a cube as shown in this figure 1. So this is figure 1 with uniformly distributed charge in its entire volume. Intensity of electric field and potential at the one of its vertex P, which is shown in the figure, are V0 and E0. So V0 is for potential, E0 is for field intensity. A portion of half of the edge size of the original cube is cut and removed from this, which is shown in this figure 2. Find the modulus of electric field and potential at the point P in this new structure. So ultimately question is this: out of a solid cube, a small cube has been taken away. This small cube has a edge length half of the original one. So we need to find again the field and potential at the same point, whereas initially they were known to us. Now we can say this cube that we have removed from the bigger one, and the point that we are interested in is P. P point is symmetrical for the bigger one and the removed one as well. Now we will be using the superposition method, and the superposition method says that we can think of this was completely filled like this, and then we can have a cube superposing at this location of negative charge, we can say, or we can say we calculate the potential and the field because of rest of it, and then the complete one, then because of this removed one, then subtract the two. So that does the job. Now consider the figure first. Now whatever this E0 is going to come at this point P, that will be because of various charge elements and taking their distance. So formula will be like integration k dq upon r square, and there has to be a direction addition, so we need to take care of the directions as well. Ultimately it will have some particular direction and particular constant. So let's say that constant is k dash, and it will be integrating dq by r square. Now, or we can simply say it's going to be having q and r square in it, and the rest will be constant because the similar geometry is going to be followed later on. Now q is going to be proportional to L cube because it's a uniformly distributed charge, so it depends on the edge length cube, and the r is going to be dependent on the length, edge length. So electric field intensity at point P will be basically dependent on L cube divided by L square. So that turn up as proportional to edge length. That means we can say the field, if we change the length of this cube or edge length of this cube, then the field will be affected directly proportional to the length. Now if we come to the potential involves Q and R. Q is L cube, R is L, so it's going to be L square. So ratio is going to be L square. So basically potential at point P is going to dependent on edge square. Now come to the figure 2. Now in figure 2 we will be using superposition method. So resultant field is going to be the original field because of the entire one minus because of the removed portion. Now interesting point is that the field due to the removed portion is going to be again the field because of the cube at the vertex, similar like this. The only difference is this cube is of L by 2 edge length, and we know the field depends on the length as well. So we'll find that the field because of the removed portion is going to be E0 by 2. So how we are getting this E0 by 2, that's the most important aspect. Let me re-explain this. Since field is directly proportional to the edge length, and the removed cube has the edge length as L by 2, and L length has a field E0, so L by 2 length will have a field E0 by 2. That's how we can find it out. So since the directions are also going to be the same, so we can write their magnitudes are going to be like E0 minus E dash. E dash is of removed one, so it's going to be like E0 minus E0 by 2. So resultant comes out to be E0 by 2. That means now the field at this point P is going to be half of the one that was initially. So that's one example, one answer. So we can check for option. We will find E0 by 2 is only on the option A. We can mark it, or we can verify for the potential as well. So potential is going to be net potential after removal is going to be the original minus removed. Now Potential depends on L square. So removed portion potential is going to be 1 upon this L by 2 square. So L by 2 square is 1/4. So it will become V naught by 4. So we can substitute V dash as V naught by 4, which turn out to be 3 V naught by 4. Hence our answer will include new field is going to be E naught by 2. New potential at that point is going to be 3 V naught by 4. And both the answers are given in this option A. Hence A is the perfectly correct response. Thank you.